Welcome back. This video is part 5 of a 9-part series on completing the square. In this video, we'll discuss how to complete the square for cases where the constant term is on the wrong side of the equation, and when the leading coefficient is not equal to 1. I suggest that you take notes as you watch the video. Get a pencil and some paper, and let's get started. I want to start off by talking about an analogy. Imagine that you're a dancer and you're learning a new dance routine. An approach you might take would be to learn the first part of the routine really well, and then once you feel confident with that part, to add on to it section by section until you know the whole routine. That's basically the approach we've been taking during the series. You've learned the first part of the routine, but now we're going to add on to it. This kind of pattern is very common in math. You learn how to do some problem, and at first it's hard, but then through practice and repetition you get better and better until it becomes effortless and automatic. But later, you start doing problems where that earlier problem is just one small part of a larger problem. You then get good at that problem, and then that one becomes a small part of a larger problem. And on it goes. Now we're going to follow that pattern for completing the square. We're going to add on to what we've already learned and solve problems where what we learned earlier will be a small part of the problems we do today. Let's review what we learned earlier. We know how to complete the square and solve for x for equations in the form x squared plus bx equals some number. An example would be x squared plus 2x equals 31. So when solving these bigger problems, this is the pattern we want, and this is the pattern we need. So imagine that you're given the equation x squared plus 2x minus 31 equals 0. Here, the constant term is on the wrong side. We need to transform this to match our earlier pattern so we can solve for x. Or imagine we have 2x squared plus 4x equals 62. Here the leading coefficient is not equal to 1. So we need to transform it to match our pattern to solve it. So today I'm going to show you how you would do those transformations to match this pattern. So we have x squared plus 8x plus 11 equals 0. In order to match our pattern, we have to move the constant term to the other side. We can do that by subtracting 11 from both sides. When we do that, we get x squared plus 8x equals negative 11. An alternate way to do this is to move the 11 to the other side, but when it switches sides, it becomes negative. However you do it, we've matched our pattern, and we can do what we did earlier to complete the square and solve for x. So we identify b equals 8 and b over 2 as 4. We add 4 squared to both sides and write the left-hand side as a perfect square. And we get x plus 4 in parentheses squared equals negative 11 plus 4 squared. On the right-hand side, 4 squared is 16, and negative 11 plus 16 is 5. We take the square root of both sides and include a plus or minus on the right-hand side. On the left-hand side, the square and the square root cancel. We get x plus 4 equals plus or minus the square root of 5. To solve for x, we move the 4 to the other side. But when we do this, it becomes negative. We have x equals plus or minus the square root of 5 minus 4. If we reorder the terms, we get x equals negative 4 plus or minus square root of 5. And here are the two solutions written out. X equals negative 4 plus the square root of 5, and x equals negative 4 minus the square root of 5. All of the previous problems we've done have just had x squared. Now what do we do when there's a leading coefficient? Like in this equation, 2x squared plus 12x equals 26. So whenever you see this, you'll need to divide every term by that leading coefficient. Not just some of the terms, all of the terms. We divide every term by 2, which is the leading coefficient in this case. In the first term, the 2's cancel. In the second term, 12 over 2 leaves 6. And in the third term, 26 over 2 leaves 13. So we get x squared plus 6x equals 13. So now we're at the point where we can complete the square and solve for x using our normal method. So we identify b as 6 and b over 2 as 3. We add 3 squared to both sides and write the left-hand side as a perfect square. When we do that, we get x plus 3 in parentheses squared equals 13 plus 3 squared. The terms on the right-hand side can be combined, and they become 22. We can take the square root of both sides, and we remember to include the plus or minus on the right-hand side. The square and the square root cancel on the left. We get x plus 3 equals plus or minus the square root of 22. To solve for x, we move the 3 to the other side. And when we do that, it becomes negative. We can then reorder the terms. After reordering them, we get x equals negative 3 plus or minus the square root of 22. And the two solutions written out are x equals negative 3 plus the square root of 22 and x equals negative 3 minus the square root of 22. Now, what if we have both situations? We have a constant term on the wrong side and we have a leading coefficient. Well, you have to do both of the previous procedures in order to match the pattern. First, we move the constant term to the other side, and when we do that, it becomes positive. The leading coefficient in this case is 3, so we divide every term by 3. In the first term, the 3's cancel. In the second term, 18 over 3 is 6. And the third term, 63 divided by 3 is 21. We get x squared plus 6x equals 21, which matches the pattern we know and want. So we can complete the square. So b is 6 and b over 2 is 3. We add 3 squared to both sides and write the left-hand side as a perfect square. We have x plus 3 in parentheses squared equals 21 plus 3 squared. We can combine the terms on the right side, and that becomes 30. We take the square root of both sides and include a plus or minus on the right-hand side. The square and the square root cancel on the left-hand side, and we are left with x plus 3 equals plus or minus the square root of 30. To solve for x, we move the 3 to the other side, and when we do that, it becomes negative. Finally, we can reorder the terms. We get x equals negative 3 plus or minus the square root of 30. The two solutions written out are x equals negative 3 plus the square root of 30 and x equals negative 3 minus the square root of 30. Now you try. Put these in the familiar form, complete the square, and solve for x. Pause now and try them yourself. We start off with 2x squared minus 4x plus 30 equals 0. First thing we do is we move that constant term to the other side, and when we do that, it becomes negative 30. We see that we have a leading coefficient 2, so we divide every term by that leading coefficient. We do some cancellation, and we get x squared minus 2x equals negative 15. That's our normal completing the square pattern, so we can complete the square and get x minus 1 squared equals negative 15 plus negative 1 squared. Negative 1 squared is positive 1. Negative 15 plus 1 is negative 14. So we get x minus 1 in parentheses squared equals negative 14. We take the square root of both sides and add a plus or minus to the right-hand side, and we get x minus 1 equals plus or minus the square root of negative 14. Now, the square root of a negative number is an imaginary number, so we can rewrite square root of negative 14 as I times the square root of 14. So we have x minus 1 equals plus or minus I times the square root of 14. We can move that negative 1 to the other side, and when we move it, it becomes positive. We get x equals plus or minus I square root of 14 plus 1. We then reorder the terms, and we get x equals 1 plus or minus I square root of 14. And the two solutions written out are x equals 1 plus I square root of 14 and x equals 1 minus I square root of 14. In the second problem, we have 5x squared plus 50x minus 75 equals 0. So we move that constant term to the other side, and when we move it, it goes from negative 75 to positive 75. We then see we have a leading coefficient 5, so we divide every term by that leading coefficient and do some cancellation, And after that happens, we get x squared plus 10x equals 15, which is our normal completing the square pattern. So we complete the square by adding 5 squared to both sides, and we get x plus 5 squared equals 15 plus 5 squared. 5 squared is 25. 15 plus 25 is 40. So we get x plus 5 squared equals 40. We take the square root of both sides and include a plus or minus on the right-hand side, and we get x plus 5 equals plus or minus the square root of 40. At this point, if you want to rewrite the square root of 40 as 2 square root of 10, you can do that. We move the 5 to the other side, it becomes negative, and we get x equals plus or minus square root of 40 minus 5. We reorder the terms, and we get x equals negative 5 plus or minus square root of 40. And our two solutions written out are x equals negative 5 plus the square root of 40, and x equals negative 5 minus the square root of 40. That concludes this lesson. If you liked it, then click the like and subscribe buttons below. In the next lesson, we'll discuss how to complete the square for cases where the linear coefficient is either odd or fractional. It'll be a fraction-packed episode. See you in the next video.